Let's take a look at this question where it says that the points -1, 5 and 15, 5 are on the circumference whose center C lies above the x-axis. Now this is what I have drawn, the circle and the 2 points -1, 5 and 15, 5 that lie on the circumference. I've also drawn the line x equals to 17, which is a tangent to the circle. So now let's try to find the radius of the circle. Taking a look at -1, 5 and 15, 5. Now, if we are able to find the distance between these 2 points, we would be able to find where the midpoint is. When we can find the midpoint, the x-coordinate of this midpoint will be the midpoint of the circle, the center of the circle. Okay. Now, this is based on the circle property that the line that is drawn from the center of the circle to the midpoint of the chord is perpendicular to the chord at 90 degrees. Right. So without further ado, let's find the distance between these 2 points on the circumference first. Recognize that both y coordinates are 5, so we just need to take the difference between the x coordinates. That makes 15, subtract -1. So this gives us 16 units. Okay. And the distance from one point to the midpoint would be half of 16, which is 8 units. Okay, so from here, we should be able to find the x-coordinate of the midpoint. Take note that x-coordinate of this point here is -1. So if we were to move 8 units to your right, this ends up with the midpoint having an x-coordinate of -1 plus 8, which gives us 7. Okay, so x-coordinate is 7 here. That makes the x-coordinate of the center to be 7. So since the x-coordinate of the center is 7, okay, and the tangent to the circle is x equals to 17. So this is where at a point where it is x equals to 17, this is x equals to 7. Therefore, we can say that the radius of the circle would actually be 17 minus 7. That makes 10 units. So that's part 1. Now let's take a look at the next part, which is to find the coordinate of C. Now we have found the first, the x-coordinate of C based on part 1. How do we go about finding the y-coordinate of C? So first and foremost, let's just put down whatever other values that we have found. Since the radius of the circle is 10 units, I'm going to put down 10 here. Okay, what else have I got? The distance between C to the midpoint of the 2 points, okay, is actually the square root of 10 squared minus 8 squared. Now, where do I get my 8 squared? Remember, distance to the midpoint is actually 8 units. So this is 8 units. This is also 8 units. So if this is 8 units, and we have 10 units here, why not we consider shifting the 10 units radius, okay, instead of it being horizontal, I'm going to shift it this way. I'm going to make it a little thicker. Here, down, okay. So this also makes the radius of 10. This makes 8. Okay. And from there, we will be able to find this vertical height. I'm going to make it a little more bold, this vertical height here. Okay. Now take note that we have a right angle. So by Pythagoras theorem, we should be able to get the answer. Let me label this as h. So by Pythagoras theorem, h is equals to the square root of 10 squared minus 8 squared. Okay, that gives 36, the square root of 36. So h is actually 6 units. Now I'm going to replace, I'm going to just put an arrow next to h, and I'm going to put down 6 here. Now, how do we move, how do we find then the y coordinate of the center? Take note that this line is actually y equals to 5. If we were to move up 6 units, we will reach the center of the circle. Okay, so the y coordinate of the center of the circle will be 6 units on top of y equals to 5. So let me put it down. Okay, and hence the center of the circle has got coordinates 7, 11. So that's our answer for part 2. Moving on to part 3. Perhaps I will use another color. Equation of the circle. This will be quite easy because using the standard formula for the equation of a circle, you already have the x and the y coordinate. Sub it in, x minus 7 squared plus y minus 11 squared equals to the radius, which is 10 squared. And if we were to simplify it, it will be x minus 7 squared plus y minus 11 squared equals to 100. So that's the answer for the third part. Now let's take a look at the last question. We want to find the equation of the tangents to the circle parallel to the x-axis. I'm going to use yet another color, perhaps now dark green. tangents to the circle parallel to the x-axis. Now, if it's something that is parallel to the x-axis, it will look something like that. Okay, and if it's a tangent, it will touch the circle at one point here and at another point here. Yeah, strictly one point. Okay, so how do we go about finding that? Take note that this is the center of the circle and the y-coordinate is 11. If we were to find the tangent, which is right at the top of the circle, you will have to add the distance of the radius of the circle to 11. Okay, subsequently, if you want to find the tangent to the bottom of the circle, we will have to subtract the value of the radius of the circle from 11 to get that tangent. So part 4, the y-coordinate of the tangent above, taking 11 to be the y-coordinate of the center, I'm going to add the radius, which is 10. And that gives it 21. So therefore, the tangent is actually y equals to 21. How about the tangent below? So in the same way, the y-coordinate of the tangent below is equals to, again, taking the y-coordinate of the circle, now we subtract the radius, and that gives us 1. Therefore, the tangent below is y equals to 1. So this concludes the question. Thank you for listening. I will stop the share now.